Hello. Okay, so as promised, I'm going to make a wildcard mask video. So this video is specifically about wildcard masks and what is going on with them. So there's a couple of things you need to know about wildcard masks. First, we dealt with masks before. We dealt with subnet masks. When we were looking at subnet masks, so for example, if we had 255.255.0.0, we would have a subnet mask that masks the first 16 bits. So if we were to write that out in binary, we would get 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So that's the binary representation of 255.255.0.0. When we were looking at subnet masks, all of these ones represented the network bits. So if there was a 1, we knew that was network bits, and all of the zeros represented the host bits. So this is just a reminder. We never, ever, ever went something like 101 or 1011. We never had ones then zeros. We always had all ones followed by all zeros. The place in which it switched from zeros to ones changed, but it was always all ones and then all zeros. So wildcard masks with ACLs are quite a bit different than subnet masks. So we don't want to get them confused, so we want to have that idea. So we know what a subnet mask is. Now we're going to look at ACLs. So in a subnet mask, the 1 bits essentially identified which were the network bits, and the zeros represented which were the host bits. So a subnet mask is used to determine the network. A wildcard mask, on the other hand, is used to determine which bits can be ignored. So a wildcard mask is used to determine which bits can be ignored. So if we have a 1, that means ignore this bit. And if we have a 0, it means pay attention to this bit. This bit matters. So how does that help us? Well, it means this. Let's say, for example, we had a wildcard mask of 0.0.0.255. I'm going to write that out in binary, so we get 1, 2, 3, 4, 1, 2, 3, 4, 8 bits, 2, 3, 4, 1, 2, 3, 4, that's 16 bits, 24 bits, and our last 8 bits are ones. So essentially what we're saying is we can ignore this portion of the address, but everything in this section has to match. Okay, we can't ignore where the zeros are. So I used the wrong version of 2 there. Has to match. So if we're looking at, say, an address, we're saying, okay, anything that's in the network, 192, I'll just stick with our class one here, 168.140.0 with the wildcard mask 0.0.0.255. What it means is that if we line these up, 0.0.0.255, all of these bits need to match exactly, but these bits over here, these ones can be ignored. It doesn't really matter in the network address. So what we get is we get all of the addresses that match this part of the address. So you'll notice in this particular address, if it's a /24 address, we're matching all the network bits. So essentially, what we're saying here is in a /24 network, because that's the first 24 bits, is match everything in this network, but ignore the specific host. So essentially, let's say I have a network that is all my guest users. So I don't want my guest users to be able to access FTP, or I don't want my guest users to be able to access a certain part of my network. So we have like all of our IT admin equipment that's on its own VLAN, and we don't want it to be able to access that. So we're going to have our router match everything coming from our guest network and ignore it. So no matter what host it is, if it's coming from the guest network, it's going to be denied. So we could do something like deny all from guest. So if we wanted to actually write out the command specifically for this particular, okay, so if we're looking to write this command, but actually put it into the command line language, we're going to need to write it as an access control command. So what we're going to do is we're going to start by saying this is an access list. We would be doing this from global configuration mode, by the way. So let's say we're on router 1 in global configuration mode. So in global configuration mode, we would write access list, access dash list, the access list that we're currently activating, deny, and we would do 192.168.140.0, and then we would do our wildcard mask, which we calculated earlier, 0.0.0.255. The next thing we would need to do, because we blocked access to that network, is just simply allow access to all other traffic. So access list 1, permit, and then we could say to match anything, 0.0.0.0, which is like our default static route, similar to that. And then the wildcard mask would be, we don't care about any of the bits that were entered in our network mask. We're going to put them all as ones, basically saying anything at all is allowed. And so what we've done here is we've specifically denied our one network and then allowed another one. In this particular case, because we are blocking the hosts, all the hosts, we can use a keyword to make this a bit easier because that's quite common. Blocking the hosts on a network is quite common. So what we could do is we could write this in an alternative form with access list 1, deny, and this time we're going to deny hosts. So we're going to say deny host and then the network that we want to deny the hosts from. .140.0. We still need to set up that permit, but there's actually a shortcut for setting up a permit. Because it's so common to say anything, match anything that we haven't already accounted for, we want to just say permit, and the option is any. So the any keyword essentially matches anything. With the host, we need to give the network those hosts are from. With any, we're literally saying anything, so we just need to say any. Nothing else needs to be added to that, which is pretty convenient. So when we're looking at permitting wildcard masks and looking at different types of wildcard masks, we want to look a bit at some examples outside of the host or the network. So quite often we are allowing or denying all hosts from a certain network, but sometimes we're not. Sometimes we are blocking a whole subnetwork, right? So that could be lining up. It could be a classful block like we have here where we've lined up right on the dot, but it could be a class list block. Okay, so let's say we're looking at the address 209.7.16.32. And we're saying, okay, we would like to block this specific person. This specific IP address is causing us issues. We want to block it. If we want to block this specific IP address, we're going to need to set the subnet mask to match every single bit available in that address. And remember that 0 means it's a match, 1 is an ignore. So if we were trying to match every single bit, we could do something like access list 1. So now we're wanting to block them all. So we would say access list 1, deny 209.7.16.32, and then we want to match every single bit. So we're going to use zeros for every single bit. So that's matching every single bit. Whereas we saw up here, using all 255s meant that it didn't match any bits. It just said, whatever, every bit can be anything. 0 means this bit has to be the same. Okay, so we can then deny that, and again, we want to then set a default access list for all others. So we would set a permit any to handle any other traffic that we had to deal with there. Okay, so let's look at a slightly different example. Let's look at blocking a subnet that doesn't line up on a classful address. So if we're looking at, for example, we'll look at that same network. So let's say 209.7.16.0, but now we're looking at a /28 address. So that means there's 28 network bits. So if we're looking at 28 network bits on this particular address, we know that at some point in this space, we're going to need to separate our network and our host bits. So we know our subnet mask, we know that our wildcard mask is not, it's going to care about the network. So it's going to care about this section. So it's saying you have to match the first section, you have to match the second section, you have to match the third section, and then it's going to do something weird here where it has to match the first 3 bits, but it doesn't have to match the rest of the network. So what we would do is we're saying, okay, this 0 can be represented by 8 bits, and we're going to need to have match the first 3 bits. So we're going to get 3 zeros, so that's the 25th, 26th, 27th. Sorry, we're going to need to match 28 bits, and the rest of that binary value that we don't care if it matches would be all those. So the wildcard mask would actually be 15. I'm going to go through that a little bit slower, but this time writing it all out in binary so you have an idea of what I'm doing. So if I open the Windows calculator in programming mode and I type in 209, we see that in binary it is 11010001. So in drawboard, I'm going to do 11001. Let me check my calculator again. 0001. 0001.7. I happen to know that 7 doesn't need a 128, doesn't need a 64, doesn't need a 32, doesn't need a 16, doesn't need an 8, but it does need 4 plus 2 plus 1. 16 is going to be 00010000, and 0 is going to be 00000000. Feel free to check my binary conversions using the Windows calculator if that makes you more comfortable. So this is 209.7.16.0 written in binary form. So if we're looking at it in binary form, we know that we need to match all of these bits exactly. So we're trying to match the subnet. Okay, so ones mean we're matching exactly. Sorry, zeros mean we're matching exactly. Okay, so zeros mean we're matching exactly. Okay, so we have 11010001. That's 209.7.16.0 written in binary form. In order to match this, we know that a 0 is a match and a 1 is an ignore. We want to match all of the network bits all the way up to, if this is 24 bits, 25, 26, 27, 28. So we want to match up to there. So what we're going to do is 0 is a match, so 0, 0, 0, 0, 0, 0, 0, 0. So that gives us a 0. 0, 0, 0, 0, 0, 0, 0, 0 gives us a 0. 0, 0, 0, 0, 0, 0, 0, 0 gives us a 0. 0, 0, 0, 0, and now from this point on, we want to ignore the rest of the bits. We only want it to match the subnet. Everything else we can ignore the value of. So we get those 4 ones. This converted to decimal gives us 15. So that's how I got the 0.0.0.15. Okay, so looking at wildcard masks, what we've discovered so far is that 0 is a match, meaning the bits have to be exactly the same, and 1 means ignore, meaning the bits can be anything. We don't care. We're just going to ignore them anyway, so it's irrelevant whether or not they match. So we can use this to get ranges of addresses. So far we've looked at all the hosts, we've looked at all of the devices on a single subnet, we've looked at the any command and the host command, but now we're going to look at is how we configure a range of addresses. So we're going to use our standard 192, here I'll do a little example thing, 168 dot, we'll pick something that we can do quite easily. So let's say .32.0. So written out in binary, we're going to get 1100.168. I'm not quite sure what that is. I'll switch to my calculator. And there I can see that it's 1010.1000. So 1010.1000. I know that 32 is going to be like so. And then zeros is all zeros. So that one's nice and easy. So let's say we had the wildcard mask. So let's say our wildcard mask was 0. Actually, I'm going to write it up here. So let's say we had 0.0.15.255. So in this particular case, our wildcard mask is going to be zeros, followed by zeros, followed by 15, followed by ones. So we have the number 15 and the number 255, as well as 0 and 0 here. So what we're going to do is, looking at these values, we're going to see about what matters. So if we look here, we can see that we really care about all of these bits. These bits, they're super important. These bits, they can do whatever they want. We don't really care what they do. So essentially, the smallest value we could get here is going to be 1100.000.1000.0010. So we've kind of come right up to that breakpoint because we know absolutely those bits have to match. And then if we were looking at the smallest possible address, we're just going to make the rest of them zeros. So we actually end up back with our network address, which is kind of handy. And then we're going to look at the maximum values. Well, the maximum value is going to once again keep all the bits that this wildcard mask said, hey, these bits have to be the same. That's why they have zeros next to them. And it's going to go, oops, sorry. So 0, 0, 1, 0. Okay, so all of these bits have to stay exactly the same. And the rest of the bits can be whatever they want. We can max them out by filling them all in as ones. So what we get here is we get from 192 to 168, 32.0 to 192.168. And now we need to calculate this maximum value, which we're going to do. We can use our simple binary and say, okay, well, there's a 32-bit plus an 8-bit plus a 4-bit, plus a 2-bit, plus a 1-bit, which gives us a total of 32 and 8 is 44, 46, 47, meaning that we have 192.168.47.255. So in the range from 192.168.32.0 to 192.168.47.255, that's what this wildcard mask will cover. So it's not the whole network, it's just a section of the network, which can be quite useful to be able to do. I'm just going to erase my calculations here. That's how we can use wildcard masks to calculate ranges, which can be quite useful. It allows us to access split up ranges into different things. So we're going to actually now look at calculating wildcards. And when we're calculating wildcards, it's a little bit different, but it's very similar. So the first thing we want to do is say, if we wanted to permit all users on a network, what we can do is we can just take the subnet and subtract it from 255.255.255. So what do I mean by that? I mean this. If we're looking at, say, a /24 network, which has a subnet mask of 255.255.255.0, we can subtract that from a mask of all ones in order to calculate the wildcard. So if we want to match all addresses, so match all addresses, or more specifically, match host bits, what we're going to do is we can just say, okay, so if we had 255.255.255.255, and we subtract our subnet mask of 255.255.255.0, what we'll find is that 255 minus 0 is 255. 255 minus 255 is 0. 255 minus 255 is 0. 255 minus 255 is 0. And we get our wildcard mask. Now, that was a nice classy address, classful address. So we're going to line up a different one. Okay, so we're going to look at calculating a wildcard mask for something that's not a classful address, so a classless address. So let's say we're looking at the /29 subnet space. So say, for example, our address was 192.168.72/29, and we wanted to mask that. So what we're going to do is the /29 subnet address is actually going to be 255.255.255.29. So we're going to need to mask 1, 2, 3, 4, 5. So that's 25, 26, 27, 28, 29, and 3 zeros, which nicely converts to a subnet mask of 248. So I'm going to go ahead and get rid of that and replace it with a 248. So 255, 255, 255, 248 is our subnet mask. So we're once again going to use the subtraction trick, and we're going to say, okay, so my address is 255, 255, 255, 255, and I'm going to subtract from all ones the subnet mask that I have. We're always subtracting from all 255s for this trick, by the way. So 248. And that should give me the wildcard mask that I need. So now, what's 255 minus 248? Okay, so we have 5 minus 8, which is like 15 minus 8, which is going to give us 7. Carries over 4 minus 4, 2 minus 2. So we get 7, 0, 0, 0. And in fact, our wildcard mask is simply, I don't know why I'm writing wildcard mask is simply 0.0.0.7. And that's how you calculate a wildcard mask. It can go into multiple columns. I'll just do a quick example of that. So say we're looking at less than a /24 network, or say we wanted to match networks in a larger section. So if we had a subnet mask of, so first I'm going to start by just writing out the standard 255.255.255.255, so I don't have to write it out twice, minus, let's say we had a subnet mask somewhere in the /23 or /22 address space. So the /22 address space is going to be 255.255. And then I know that at this point, I have 16 bits. So I'm going to get 17. Oops, sorry. These are going to need to be network bits. 17, 18, 19, 20, 21, 22. Finish off the 8 bits. And then the remainder of this subnet mask would be zeros. So what we know is that we have now 1, 1, 1, 1, 1, 1. So we're going to go ahead and switch over to our Windows calculator in binary mode. 1, 1, 1, 1. 1, 1, 0, 0. So we have a full 8 bits, and we can see in decimal that's 252. So we know that this portion becomes 252, and the last portion becomes 0. So the way that we can calculate that is we're going to separate or subtract each octet. So 255 minus 0 gives me 255. 255 minus 252 gives me 3. 255 minus 255 is 0. 255 minus 255 is 0. So in doing so, we can figure out what the new wildcard mask is. Okay, so this is the wildcard mask for a /22 network. This is a wildcard mask for a /29 network. And we can kind of work from there. And that's essentially how you're calculating wildcard masks. So it's really crucial that when you look at a wildcard mask, you're remembering that zeros means that we're going to match the bits for sure, and 1 is that we're going to ignore the bits. You'll notice I've said this a whole bunch. but you need to realize that's very important. So the 0.0.0 wildcard is the match everything. So match exactly. That's, I want to block one specific IP address. The 255.255.255. Wildcard is allow, or is like match nothing. So essentially anything is allowed. So it's the equivalent of that any command. So if you're matching nothing, you mean by default everything's allowed through, no issues. We looked at the any command and the host command, keeping in mind that this one is the equivalent of that any command. Oops, let's make that a Y, not a G. So yeah, that's pretty useful. You can also use none in the place of an all zero wildcard mask, but you might have some issues with that. So I wouldn't do it in the context of this course unless you're specifically told to. So there's some activities in 7.1.2.6 and 7.1.2.7 that you might find quite helpful, but hopefully this helped clarify the whole wildcard mask thing. The biggest thing about it is that it starts with zeros and goes to ones, and the zeros mean it needs to match that exactly, and the ones mean it's not matching. So essentially, if it's not matching anything, then nothing's getting stopped by that rule. If it's matching everything, then that address that matches exactly is going to get stopped by that rule, or permitted or allowed by that rule, or denied by that rule. So if we're looking at like one address, this is the one we're looking at. If we're looking at any possible address, this is the one we're looking at. But more often, we're using these other ones in here where we're talking about a specific section, or like I said, you can use that host keyword, which I swear I showed you. Yeah, you can use that host keyword that we saw up here. Okay, so hopefully that helps clarify some of the wildcard mask things. If you have any more questions, please feel free to ask me. And there will be another video about how we're configuring ACLs up shortly.